அன்னைக்கு மாதிரியே பிரச்சனை பண்ணுது. போக மாட்டுதோ. இன்னைக்கு இதே மாதிரி தான் வந்துச்சு. எனக்கு இங்கே லைவ்னு காமிக்குதே மேடம். ஆனால் இல்லையே. இப்போ ஒரு லிங்க் போட்டிருக்கேன், இதை பாருங்க. டிவிஷன்ல இருந்து வந்துருக்கும் பாருங்க. டிவிஷன்ல இருக்குங்களா? ரெக்கார்டிங் ஸ்டாப் பண்ணிட்டேன் மேடம். இது லைவ் மட்டும் இப்போ போகுது. மேடம் மைக் ஆஃப் பண்ணியிருக்கேன், ஆனால் எப்படி கேட்குதுன்னு தெரியலையே. கேட்குது, கேட்குது. புது பிரச்சனை. மேடம் இந்த மைக் ஆஃப் பண்ணி ஆன் பண்ணல என்ன வருதுன்னா, என்னோட ஜிமீட்ல இருக்கக்கூடிய கனெக்ஷன் ஸ்டாப் ஆயிடுச்சு. Madam, good morning. Okay. ஆமா. மத்த ஸ்கிரீன் பண்றது மாறுதா? மாறாது. இல்ல மாறல. ஆ, அப்படியா? அதெல்லாம் வந்துச்சுங்களா? ம். எனக்கு மேடம் இந்த மைக் ஆஃப் பண்ணாலும் ஜிமிட் மைக் ஆஃப் பண்ணாலும் ஓபிஎஸ்ல இருந்து மைக் ஒர்க் ஆகுது. இன்பில்ட்டா வேலை செய்யுது அங்க இருந்து. சுபஸ்ரீ ரெடி தானா? சுபஸ்ரீ ஜாயின் பண்ண சொல்லுங்க. மேடம் எந்த விண்டோக்குள்ள போனாலும் அது இங்க டிஸ்ப்ளே ஆகுது. ரெக்கார்ட் ஆஃப் பண்ணி தான் வச்சிருக்கேன். நமக்கு மட்டும்தான் பண்ணிருக்கேன். ம். வந்துட்டாங்களா? சுபஸ்ரீ மேம் ஆட் ஆயிட்டாங்களா? தேவி மேம் வந்துட்டாங்க. சுபஸ்ரீ மேம் வந்துட்டு போயிருக்காங்க. அங்க இருக்காதுங்க மேம். மொபைல்ல தான் பேசுறேன். அதான் சும்மா நீங்க பேசுங்க மேம். குட் ஆஃப்டர்நூன் சுபாஸ்ரீ மேம். சுபஸ்ரீ மேம், குட் ஆஃப்டர்நூன். ஜிபி இல்ல நான் கூப்பிட்டேன். அதுல சும்மா வாய் பேசுறேன். சுபஸ்ரீ மேம், குட் ஆஃப்டர்நூன். தேவி மேம்,
Hi all, good afternoon everyone.
குட் ஆஃப்டர்நூன். குட் ஆஃப்டர்நூன். தேவி மேம், தேவி மேம், Okay, madam. Okay, yes. Good afternoon, ma'am. Devi ma'am, can you able to unmute your mic? Devi ma'am. Devi ma'am, can you able to unmute your mic? Ma'am, உங்களோட மைக் அன்மியூட் ஆக மாட்டேங்குதா? ஆகுங்களா? அன்மியூட் பண்ணி ஹாய் மட்டும் சொல்லுங்க.
Can you hear my voice?
Yes, ma'am, it's audible.
Sir? Sir, your voice is not clear, sir.
Ma'am, now? Ma'am? Ma'am, it's audible?
It's audible, sir, Sadish.
Okay, ma'am. Thank you. Saranya madam, can I start recording?
Good morning, students. Good morning, ma'am. On behalf of Leilani Publication Press, I welcome Dr. Subhashri ma'am, Professor for Department of Computer Science, Allahabad University, to start the welcome address. Thank you, ma'am.
Yeah, thank you. Good afternoon, everyone. It is my distinct honor and privilege to welcome you all to this second National Research Workshop on a perspective and challenges in onboard processing of hyperspectral imagery. On behalf of the organizing committee and Leilani Publication and Press, I extend a warm and heartfelt welcomes to each of you, participants, distinguished speakers, and special guests who have gathered here from across the country. This workshop marks an important opportunity for us to unite as a community of researchers, scholars, and practitioners, each dedicated to advancing knowledge in our respective fields. It is my great pleasure and honor to welcome our distinguished guest, Dr.T. ARUMUGA Devi Madam, Associate Professor, Center for Information Technology and Engineering, Manonmaniam Sundaranar University, Tirunelveli. Her impressive academic journey, backed by 14 years of teaching experience and 10 years of research experience, has made her a respected figure in the fields of video and signal processing and remote communication. With 46 journal publications, multiple books, and extensive contributions to conferences, her research has significantly impacted her areas of expertise. Her dedication to research is further evidenced by her ongoing guidance of 4 PhD candidates. We are truly fortunate to have such an accomplished scholar and educator with us today. We are eagerly looking forward to hearing her insights and learning from her experiences today. Once again, I extend a warm welcome to Dr. T. ARUMUGA Devi and thank her for graciously joining us. I extend a warm welcome and sincere gratitude for Dr. M. Satish Kumar, Managing Director, Leilani Catty Publication and Press. I would like to thank our organizing team whose hard work and dedication have brought this workshop to life. I encourage each of you to actively engage in the sessions, share your insights, and take full advantage of the wealth of knowledge present in this event. Together, let us embark on this existing journey of discovery and innovation. I wish you all an enriching, productive, and enjoyable workshop experience. Thank you all.
Thank you, ma'am. Thank you, Subhashri ma'am, for our heartfelt welcome address. I would like to welcome Managing Director Dr. Satish Kumar, Leilani Catty Publication Press, to give a special address.
Good afternoon to one and all. I would like to thank Dr. Subhashri to give a welcome address, and she is my best friend. She is a batchmate for my Master of Philosophy in 2012 at Alagappa University, and presently she is working in Alagappa University. That's very happy to share in front of all the participants and special guests. And it's my pleasure to introduce our esteemed speaker today, Dr. ARUMUGA Devi ma'am, Associate Professor at Center of Information Technology and Engineering, Manonmaniam Sundaranar University, Tirunelveli. Dr. ARUMUGA Devi ma'am is a highly respected researcher in hyperspectral imaginary processing and onboard computing. Her work has had a significant impact on real-time data processing and applications across various sectors, including environmental monitoring and defense. She has published 46 research articles in various journals and 12 articles in conference proceedings, and published 2 books. I warmly welcome Dr. ARUMUGA Devi ma'am. We are excited to learn more from you. Thank you, ma'am.
So good afternoon.
Devi ma'am, you can start your session, ma'am. Please present the PowerPoint.
Good afternoon, everyone and all present here. So my topic is perspective and challenges in onboard processing of hyperspectral imaging. So can you see my slide?
No,
Anyone?
Ma'am, here it's displaying your Gmeet. Can you go for the presentation slide?
Yes, sir. Is it viewable to all?
No, ma'am, PPT is not displaying. Your Gmeet is presenting here. Kindly present your PowerPoint, ma'am.
Yes. Now can you see my slide?
Yes, ma'am. Yes, ma'am.
Okay.
Please switch it to full screen, ma'am. Yeah. Okay, ma'am. Please continue.
Okay. So I am very happy to deliver a lecture related about perspective and challenges in onboard processing of hyperspectral imagery. So myself is Associate Professor and Center for Information Technology and Engineering, Manonmaniam Sundaranar University, Tirunelveli. So I hope you are enjoying this section because this is a research workshop. So only we have to focus what is the main application area for doing the research in hyperspectral imagery. What is the latest technologies are involved in this during this workshop. So I hope you are learned from new things from this workshop. So outline of my presentation is related to the introduction of, about hyperspectral imaging and electromagnetic. What is the electromagnetic spectrum? How do you differ the spectrum in various cameras, that is hyperspectral cameras, and what is the how do you analyze the spatial and spectral information, and what are the uses of hyperspectral data, what are the applications in this, and what is the research trends in analyzing the food using hyperspectral image data, and what are the research trends with LOPS, that is line of protective sensation in using this hyperspectral image data. Next, it's the latest technology. What is the onboard processing of hyperspectral imaging? What is the overview of for this one, and how do you challenge the onboard processing in the upcoming research area? So apart from that, I could conclude the future directions related to this research, and we have to focus some little practical approach related to Python and Python script we have to discuss. So about the introduction, so hyperspectral imaging is used to identify the materials or define the properties of it. You have to study how the light is to be interact, and we know that that is hundreds of images are to be collected from spectral bands, that is the electromagnetic spectrum. So normally it takes the spectral ranges 400 to 1000 nanometer with the help of single channel images, and we have to split the spectrum in normally 290 bands with the range related to 930 to 2500 range. That is with the help of this spectral resolution is 5.45 nanometer. So here some of the research terminologies are involved here. That is, you have to focus the mineralogy and how do you take the agriculture medicine, and how do you concentrate the chemistry, forensics, and what are the remote sensing applications are there, and comparing the multispectral and hyperspectral. You have to take only fewer bands in multispectral, but you have to concentrate that hundreds of bands and thousands of bands in hyperspectral. Next, we have with the help of the cost and time, you have to consider some image hyperspectral images. You have to challenge to analyze and how they are to be interpreted manually with the help of this high dimensionality and volume of data if you want to process it. So this is the one hyperspectral data is to be taken from that hyperspectral camera. That is list of contiguous bands are inside it. So here from that contiguous bands, you have to get that wavelength versus reflectance graph. You have to get it with the help of different ranges. So that is very near infrared range and short wave infrared range and that is long wave infrared. So based on this contiguous band, you have to get that reflectance curve. That is, you have to measure only the reflected solar radiation in many contiguous spectral bands. So this will help the parameters, how you can derive the parameters based on the vegetation, soil, water bodies, and artificial surfaces. So what are the uses of hyperspectral data? You want to distinguish the similar color object and with the normal object. So apart from that multispectral data, we don't get that color information for that exact object, what it is. So with the help of hyperspectral data only, how to get the spectral information and color information, and how to deal so many spectral bands, that is to be with the help of the spectral range. So what is the spectral range is 400 nanometer to 2500 nanometer. So this range only how to produce all the spectra of all pixels in the scene. So you have to extract more detailed information from the traditional multispectral data. Next, what are the applications for this hyperspectral data is, you have to get that band selection, then transfer modeling is there. Next, what are the spectral libraries are there? From that, you have to analyze the denoising and restoration and super resolution. And how do you classify the data? What are the how do you segment the data with the help of some target and anomaly detection? And how do you change the detection? And what are the time series HSI analyze data? How it has happened for real time applications? And through the artificial intelligence, major upcoming field nowadays. So that field also you have to apply it in hyperspectral imaging. Next, what is the mineral mapping? How do you map the mineral, and lithogenic mapping and geological applications? So these are some examples of applications. You have to develop this hyperspectral data in this area, and you have to focus what is the quality of the water, how we can be monitor, and what is the environment soil is there. Then how do you map the mineral? Then what is the health of the vegetation, and how it is to be monitored using this hyperspectral data. So a lot of application field. So by focusing this few applications, that is to be demonstrated with the help of this graph, that is graphical representation, that is with respect to wavelength and reflectance. We have to take the minerals. First we have to take the minerals in between 400 to 2000 nanometer. So it is identified as kaolinite and gypsum and illite and dolomite and calcite and chloride. So with the help of this range only, how to get that spectral graph. So spectroscopy, we know that is how light behaves in the target and how it can be recognized materials based on their different spectral signature. So spectral signature is you have to identify from the spectrum of the material. So we have to identify kaolinite from the red line. So that is you have to differentiate the color variations with the help of some object. What is the object is present? So based on this, you have to electromagnetic spectrum. It describes the amount of light in different wavelength. So the last one, that is soil mapping. So how ferrous material content is present in between 0.5 to 3. So in between this percentage, the ferrous content is larger in the area of that is red intensity. So with the help of this wavelength versus reflectance, this graph should be from 400 nanometer to 2400. The graph should should be high in this range, and you get that soil type is ferrous material. So likewise, you have apply this same concept in dry vegetation mapping also. So another application is urban surface material, and you have to identify some materials, that is oil, dust, mine waste, and pollutants. What is the how the plastics looks like. So these are some hazard materials is present in our earth. So how do you remove this this plastics from this ground? So so you have to analyze it by means of some pollution mapping and urban surface area. So water quality mapping. So based on this spectral graph only, how to identify which material should have harmful effect in our earth. So how to identify it, and based on this spectral graph. So in between this 500 to 2500 nanometer, so you have to take 60% is oil present and 40% is water present. So this based on this spectral graph only, how to identify it. And the second one is how to quality is to be, water quality is to be identified with the help of this fococaine content is present in between 440 nanometer to 678 nanometer. So in this case, you have the graph should be higher to then it peak level, then again as lower level, then it is it reaches the point 700 nanometer, it goes high, afterwards it decreases. So this reflected curve is identified, the water quality is present in this 700 nanometer, and you get that this content, this piconium content is present in this case. So likewise, you have to every material and every object is to be identified clearly with the discrimination of this hyperspectral data. So this is you have to analyze the comparing the multispectral and hyperspectral data. Many surface information can be derived more accurately with the help of this hyperspectral data, while we are taken only the certain applications. So vegetation is in green color. This BAS range to short wave infrared range. So in this range, this vegetation is normally from this 0 to 2.3 in this range. This graph wavelength versus reflectance graph should be low, and it is to be for constant for the particular period of time. Again, it is decreases, and again you have to get some constant value, increases and constant value. Likewise, the vegetation graph is there. So this graph is obtained from the sensor, that is Landsat 8 and Zenithal 2 sensor. So different sensor we give the that is what exact material is present. So based on this sensor spectral range only, how to identify it. So this is the spectral cameras, and what is the spectral cameras? Hyperspectral camera is normally for VS and VNR range is normally 380 to 800 nanometer, and 400 to 1000 nanometer for very near infrared range. So in this spectral camera is we need it's a very essential tool and for both industry and science, and it is mainly for providing some spectral information for each pixel. So you take this, if you want to combine the high resolution and hyperspectral spectral cameras, that is to be for uncooled detector and optics, it is to be both are combined. So that sensor is called long wave infrared spectral cameras. So this high sensitivity model is spectral range is normally the sampling period is 200 nanometer. Spectral band 30 spectral bands only it is splitted. So hyperspectral this high sensitivity camera is suitable for industrial and chemical imaging applications. So next high resolution model cameras, if you consider it, it is divided into 85 bands, and the spectral sampling is near about 70 nanometer. So if you consider the infrared source is used to illuminate the sample. So that is to be this both. If you want to combine this HS and HR models, if you want to create it, so you have to combine this things, and you have to apply it in color control shorting and scanning of artworks and flat panel display measurement and print testing and counterfeit detection and life science application and plant vegetation research, environment monitoring and hyperspectral microscopy. And you have to inspect some of the vegetables which are to be weak or which fruit is hygienic, and you have to take this HS and HR models cameras is applicable for this applications. Next, comparing this some strategies for analyzing hyperspectral technologies using research and commercial imaging spectrometers. So sensors, a lot of sensors are available. So only few sensors I focus it for AVIRS and AISA and CASI and HypeMap and Probe. So these sensors. So for HyMap sensor is applicable for the country, that's Australia. It is that is how many bands are to be in this 128 bands are to be allotted for this HyMap camera. So the wavelength is range is 0.4 to 2.45. So from this range you have to get that band, that 128 band. So that much amount of information you can get it from this HyMap camera. So this is the electromagnetic spectrum. You know that is the electromagnetic spectrum. That is, if you consider much of the, that is, it describes the amount of light. Spectrum is describing some amount of light in different wavelength. So it shows how much light is to be emitted and it is to be reflected or transmitted from the target. So how much certain color this light contains. This is the electromagnetic spectrum, it defines it. So you have to present the spectrum in a graph on a scale of intensity and wavelength. So normally the radiation is between 372 nanometer to 730 nanometer. So this is the human visual system. We can see the color images like RGB colors. That's red color, green color and blue color. So RGB cameras is just visible this range only 372 nanometer to 730 nanometer. Likewise, our human eye preserve the information from this range only. So the curve in the spectrum of the solar radiation is reaching the Earth's surface. So that is described in this electromagnetic survey cosmic rays range and gamma rays, this range, X-rays and ultraviolet. So in between this RGB, you have to extend this different rays based on the electromagnetic spectrum. So the white light is nothing but it's a mixture of all wavelengths. So next one, visible light. So here, what is the range for green color? 490 to 560. This range only we have to our eye recognize this is the green color. Then 450 to 490. That color is identify our eye. That is blue color. So based on the ranges only we have to identify which color is present. That is based on the material or object. Any object is present in our earth. So next is you have to get the spatial and spectral analysis. Just a minute. So this you have combined the HSI data and HRI data. That is hyperspectral imaging data is to be incorporated with the help of HRI data. Both are co-registered and you have to enhance the sharpened HSI data. That sharpened HSI data is to be collected from that background classification and anomaly detection data is to be extracted from the HSI data, and you have to combine that spatial edge detection and sharpened image data. Both are combined, and you have to frame as an enhanced classification and target detection. And finally, you get the target detection and identification at the from the enhanced background classification and target detection. So this spectral matched filtering algorithm, we have to apply it, and based on the material spectra, and you have to get the target identification and detection. So this is the simulated data generation from the HSI truth data for HSI and HRI data fusion. How to fusion the data here? So truth data is to be get it from that range is 240 meter. So in this range, you have to integrate the both bands, spatial and spectral bands. You have to integrate it, and you have to take that band integration, simulated HRI data. You have to take it, and spatial degradation, simulated HSI data. You have to take it. So both are fusion it, and you have to make a HSI and HRI data. So this, if you want to fusion this data, that fusion data is to be applicable for spatial and spectral analysis. That is for sharpening the image. If you want to sharpen the data, this you have to take the integration. So both integration is needed. So HSI and HRI. That HRI means high resolution imaging data. So this is the actual spatial and spectral. How do you get that spatial and spectral information? So images normally occurred in narrow bands as well as some wavelength bands only. So you have to take the brightness values for a single raster cell, position in the hyperspectral image, and you have to get that normally the images are to be stacked in one over another, and it is in the like a stack. So you have get that for particular band, if you want to take, means that information only analyzes in the graph. So that is wavelength versus relative brightness. So the brightness values versus wavelength shows the continuous spectrum for each image cell. So this is the imaging spectrometry. So this spectrometer, what is the purpose of spectrometer? This is the instrument that splits the incoming light into spectrum. So you have to measure the reflectance spectra is the common way to use the hyperspectral imaging. Imaging spectrometer is nothing but it's a hyperspectral camera. So we can measure the thousands or hundreds of spectra in it, and the collected spectra are used to form a image of the target in a way that each image pixel includes a complete spectrum. So we have to provide this HSI 3D data is called a data cube. So this light from any ground resolution cell that is focused in one mirror, that is optic or any other optics. So that is to be reflected or refracted or diffracted. So based on the dispersing element, then it is focused to the optics, imaging optics, and you have to take the wavelength from that and get that wavelength from that based on the any one detectors. So here some sensors use some multiple detector arrays that will measure the hundreds of narrow wavelength bands. So this is one research area. I can apply the how do you analyze the food quality, and normally quality of the food is very, very important nowadays. So without the quality of the food, there is lot of problems maybe arise. That is due to health is to be affected, and we don't concentrate. If we don't concentrate our health, then normally our internal organs should be affected, and we that is death rate is also increases due to the hygienic food is not available nowadays. So for this, I focus this analyze the food quality in terms of hyperspectral imaging. So this is how you can confirm the quality of the food. That how do you minimize the risk of food dispersion, and how do you increase the safety using this hyperspectral imaging data only. So I use machine learning algorithm. I want to detect this hyperspectral data and how what are the foods are to be defected in which range, and you have to remove that food through any one terminologies. So next one, onboard processing. What is the onboard processing means? So here you have to use any hardware oscillators that will process the hyperspectral imagery, and it is to be still on the board. So it is a very promising field for future research and application. This is applicable only in remote sensing application, and it is also applicable in non-remote sensing application. So considering that challenges, only some key issues are to be arises when you challenge the onboard processing. So one is you want to make the noisy data nowadays. So this will have some atmospheric correction for each zero level, and you have to make the training data set also. And the training data sets is to be increased means then that is to be insufficient for the training model. So what you do, you have to focus on the assessment and testing of different network structures, and you have to simulate the data, and you have to analyze the self-supervised learning method, and because of lacking of the training data. Next, another challenges for onboard processing is there is a new domain you have to focus it and you have to study it, and what are the new possibilities are that for a remote sensing domain, and how do you automate that hyperspectral satellite payloads. So based on that, you have to solve the problem of onboard processing. So this is the onboard processing architecture. So here this ground segment data you have to between the server to gateway there is a core network is needed. So here you have to train the model, and you have to what are the defining hyperparameters are there, and what are the weights of this network structure, and so here from the satellite to earth and earth to satellite. So the uplink and downlink concept is there for considering AH chipset for model inference is there. So this detected bounding box is used to get that user segment. This is one architecture is, for this onboard processing. So here this what is the challenges for data is to be a low latency data is available for this onboard processing. Here time and energy required to download the data is a major factor in the data latency. So what do you do? How to effective use of satellite time, you have to focus it. So another thing is in-orbit processing is there. So here how much amount of data is to be transferred to the ground station, and from the ground to satellite you have to send what are the data is to be transferred. So that if you do this feeder link based on this, you have to assess the time to information and gathered some information by the satellite. So next one, this is one method, proposed method for quality is to be checked. That is hyperspectral image-based meat quality classifier. So this is one based on the fuzzy contextual neural network for food quality analysis using hyperspectral image data. This focus the blocks, that is hyperspectral food image context extractor and hyperspectral context fuzzy classifier and CNN for food quality analysis. So this objective of this one hyperspectral data for food quality analyzing is you have to get the food attributes like the texture, color, size, shape, and molecular particles, and you have to detect the excite part of the data, whether the food is to be carbohydrate or it is to be fat or it is to be protein or water or some unusable core. So finally, how to use the QA, and that is utilized using a tuned convolution layer and heuristic activation operation parallel element merge layer with the help of some connector layer. It is used for classification. So next, you have to focus the how the tuned convolution layer, heuristic activation operation, parallel element merge layer, and a regular fully connected layer for classification using CFQA method. So the quality of foods is to be tested using some various fruits and vegetables. Uh, so in this research, what so in this research work, I want to test the focus the DL algorithm, deep learning algorithm, and we have to assure the food quality. And the proposed model which uses the both spatial and spectral data that will improve the HSI grouping. So group deep learning approaches which uses the 3D CNN as well as residual 3D CNN for HSA recognition is implemented. So another thing is here we have to focus 7.86% of average values with the performance matrix, accuracy, precision, sensitivity, and specificity. So here the radiance and reflectance. How do you measure the radiance and reflectance? We know that the spectral reflectance is a property of ground features, and you have to measure only the precious data and accurate data, which we have to use the whether airborne or satellite hyperspectral sensors. So here 25 image spectra is measured by the AVIRS sensor that will have the spectral information, and you have to focus the calibrated data, and you have to any one transformation you have to apply it. So this is one radiance. How do you measure the radiance with respect to the wavelength versus relative brightness at sensors? So here average measured brightness for a portion of player surface. You take the player surface, that is red square at right point is to be focused. So this spectral graph is in between 0.5 nanometer to 2.5 nanometer. So it is periodically decreases, afterwards it increases. Likewise, finally, it reaches the 2.5 nanometer. So this graph will determine whether the player surface is to be have that brightness or not. So this is the existing method in this using hyperspectral data. That's a PCR analysis, PLS DA model, and PLS DA and radial basis model using SVM model, and correlation analysis, that is real-time impedance analysis, and integrated VNA switch to 12 model, and binary classifier using stacked auto encoders. This is one publications using this food quality analyzer, how performance matrix is to be matrix on hyperspectral image using this food quality analyzer. So this paper only published. Another paper is published on that is journal, that is International Journal of Uncertainty, Fuzziness and Knowledge-Based Systems. So here we have to take the classification stage using deep learning. So for this one, we have to focus different quality of meat products like beef, pork, mutton, fish, chicken, anyone is very important nowadays. So here the food safety is one of the major thing nowadays. So here we have to protect our health and um, so WHO, what it does is just death rate is normally increases in, because of the quality of the food is lagging only. So meat products normally some of the characteristic aroma, color and texture, calories are there, and nutrition, etc. So what is the we want to need HSI technique only. We have to identify the disease, any type of disease in the not only agriculture, in the crop, any field. We have to identify what type of disease is there, and we have to focus both imaging techniques and spectroscopy. We have to make direct recognition of numerous components, and you have to spatial distribution in the manufactured one. So some of the components inside it: light source, spectrograph, camera, and translation stage and computer. So this based on this only, this camera focus the focus the any meat or any chicken or whatever it present. So you have to quality of the meat is to be analyzed. So that is the so that concept is based on IMF is the main factor, and we have to measure the color tenderness in this case, and during CAD, that is with the help of AI and CAD, we have to minimize the manual efforts, and time complications also be reduced. And we know that the efficiency of the DL algorithm that will reduce the computation overhead, and we have to enhance the better results. So so this is also we have to solve some of the issues when the image of the meat is enough to carry out some entire detection and classification procedures. So yeah, ML models only, we have ML models as well as DL techniques only, like nearest neighborhood, ANN, KNN, SVM, and RN, recurrent neural network, CNN, FCNN, and DCNN. So both are efficient for handling the detection and classification for any kind of problems like meat quality inspection. Okay. So this is the flow diagram for this hyperspectral data, how the HSI file is to be taken from the meat, and how do you detect detection and segmentation is based on the surprise and unsurprise models. So only nearest neighborhoods, SVM and KNN is surprise learning model, and remaining CNN, KM is and EM is incorporated and unsurprised model. So based on this model, from lot of advantages and disadvantages also there. So you have to remove the disadvantage. We have to focus only the advantage of how the precious accuracy is there, and how do you implement the way in simpler manner, and how do you train the model, and based on this NNN and SVM and KMN. Then based on the unsurprised model, we have to focus no need for labeling purpose, and self-learning is capability is increased, and unlabeled data, there is a training should be very simpler one. So for the detection and segmentation, that is we already discussed in the advantages and disadvantages in the last slide. So I focus what is the objective of this one is. So HSI data is normally concern the food products like efficient FQA that is to be introduced, and you have to enhance the vicious detection. Like abnormality identification is to be performed with the help of some characteristics of meat products. So, what is the objective of this one is the you have to analyze the food products like meat products, fruits, vegetables, and leafy foods with some set of data. So this is some literature review for this analyzing the food that is equality detection approaches are also done in HSI framework only. Here, what is the achievements for this one? New equality parameters and freshness attributes are to be delivered in this equality detection approach. So next proposed method using HIMQC method. So it's mainly 3 blocks. One is HFSC, HCFC, and CNN. For FQA, that is named as CFQA. So HFSC, we have to take the accuracy and precision, and we have to get the spectral photograph. So this is the rule for this one. How the attributes are to be equal. That is, if you satisfy the rule, attribute is equal to attribute 2, then it is a shape. Shape is circular. Likewise, you have to apply the rule, and you have to identify the shape of the thing. That is square or rectangle, trapezoid, so pentagon or hexagon. So from this proposed method, we have to get the HSI is passed from left to top and right to bottom in the raster scan method. So next, FQA on feed and poultry products. So here, this applicable in industrial, nutritional, and controlling and toxicological and proper features are to be based on the, if you want to protect the quality of the meat. Next one, if you consider the practical and industrial work, that is to be focus the food in old style methods that will applicable in biochemical and physical feeds. So next, if you want to focus the data in that will in the deep learning algorithm. So this multi-layer neural network consists of convolution layer and pooling layer and total connection layer. So this proposed method is based on the support vector machine, that is layer of NNN with the pivot disappointment. So this is the block diagram for data processing. So database, from the database, you want to pre-process it and segment it, and you have to extract the features. Finally, you have to classify it and detect the one. I think, can you view the PowerPoint slide? Hello?
Ma'am, tell me, ma'am.
It's can you view this my slide, sir?
Ma'am, it's working, ma'am.
Yes, yes. Okay, sir.
Yes, ma'am.
So lot of image segmentation calculation are to be there for using any one technique, that is thresholding technique, or any one deformed models if you want to say use it, and for the segmentation purpose. So next, we want to go through the thresholding. How do you calculate the thresholding means? Based on the edge-based, local-based, and crossbreed only. So thresholding is, we know that is image hooked on two groups. That is, one is importance zone and another one is base zone. So here, what are the pixels is to be in the similar dim print that is placed as a base. class here. So in the classification stage, we want to need that the similarity of distance metric estimated measures are to be uh, get it from one KNN algorithm. So K number of neighbors at that point base and resting only the Euclidean distance is to be carried out for every class, and you have to take the amount of knowledge points are to be verified, and you have to get the novel position is to be found for the food quality evaluation. So this is the structure of proposed recognition and classification scheme. So hyperspectral images taken and it is to be segmented by using Oates algorithm, and another algorithm is we want to need the pixel wise classification by 3D CNN. So here the segmented data has to be given as the neighboring regions. Pixel as for every segmented pixel is given as to the input of the neighboring regions, and that regions data how to classify the spectral and spatial classified from that 3D CNN data. So another for SVM classification, you have to use the kernel method that will give the SVM fit for each class, and you have to take the product for the kernel model, and you have to get that exact information what it is there. Next, for calculating high dimensional feature space, kernel function is used to need for getting the dot product. Next, SVM is used to give the necessity for how the classifier is there, what classifier will do the better accuracy. So SVM focus, these are the real-time problems. If you use the SVM, that is the vein recognition, test classification, images classification, and bioinformatics. So apart from the morphological arrangements, we have to get that what is the shape of the product is there. So here we need a number of distances from the finder to the model surface. We have to result only the unparalleled variation in the length of the optical bay. So this is the HSI data whole infrastructure for this one. That is when hyperspectral image acquisition is based on dark reference, sample, and white reference. From that acquisition, you have to get that dark reference image and hyperspectral image and dark reference image. So both three things are calibrated using the formula, and how to get the hyperspectral reflectance image, and from the hyperspectral reflectance you have to focus the spectral extractant and pre-processing dimensionality reduction. So both are combined, and you have to get the efficient wavelength selection from the selected image. So from the selected image only, you have to pre-process it, and you have to extract the features, and you have to finally the classify it. So this is the basic architecture of HSI data system. For the time limitation, I little bit skip it for this proposed model using HSI data set. So only a few things I will explain it, and I will go for next that is practical section. So here sensor data is to be that is focused and based on the 3D cube data, and you take the non-uniformity of the sensor data, and you take the from that uniformity of the data, you have to calibrate the wavelength, and finally sensor calibration is there, and you take the library data. From the library data, you have to take the load image and get the correlation of that one, and you have to finally detect the information. So from the detection, you have to gather the detected image, and you have to group it, and you have to color composite it, and you have to finally target is to be detected. For the third step, what you do, you have to collect the sample one and you have to refine the library, and finally effective band is final at the fifth stage. So your proposed, that is our proposed model, is mainly focused the 5 steps. Based on this, this is the hyperspectral camera input image, that is from the context, food image context extracted only. You have to classify the fuzzy classifier. You have to classify needs a CNN algorithm. That CNN is based 3 layers. One is tuned convolution layer, heuristic activation function, and parallel element merge layer. So, how to detect the quality of the food using IDA, and finally the output images has the better accuracy. So, this is the results. Some of the results I achieved in this hyperspectral environment. So, this is the graph I can obtain from the given data. So this is the graph for hyperspectral microscope image evolution, and this is for beef stick hyperspectral, how it is to be displayed using this algorithm. Next, some classification procedures. So here, how the CNN algorithm is better when you compare the traditional CNN. You have to enforce the local connectivity pattern for each neurons of adjacent layers using some of the layers, that is convolution layers, max pooling layers, and fully connected layers. So this is a diagram for a traditional CNN model. So comparing CNN model, I focus only the custom CNN model. So here residual learning, multi-scale filter bank, both terminologies are used, and you have to focus the data from the input and get the output in efficient manner. So this is the architecture of CNN with some filter banks. So with how the filter concatenation using this pooling layer, and how the data is getting from the input. And finally, what is the exit output is there. So we know that this is a formula for accuracy. So how the accuracy value is based on the performance of the approach. So this accuracy only we have get that correctness value we can detect. So sensitivity, we know that how many true positives is to exactly identify based on the test to check the quality of the food. So this is the formula. Then sensitivity is also what is the ratio of the true negatives, the summation of true negatives and false positives. So MSC, we have to measure the quality of the reconstructed image compared to the original transmitted hyperspectral image. So PSNR, we know that it's measuring the quality of the reconstructed images at the receiver. So apart from the future direction, the performance of image detection and classification would be improved by some classic convolution layers of CNN. So from this conclusion, the proposed model should have some better accuracy and precision and sensitivity and specificity, and using the methods such HFICE and HCFC and CFQA. So how much precision we can get it from this? 97.23%. So these are the references. So another research is towards this LOPS. This is loss of productive sensation. This is for locating patients with vascular disease. How the blood vessels are to be repaired based on the hyperspectral data. So here the overview of this research is diabetic mellitus. We know that it's a complicated disease So diabetic foot ulcers is a leading disease, and that is World Health Organization is analyze this diabetic foot ulcer, and maximum death rate is normally nowadays it's more when you compare the other disease. So we have to predict this terminology, and we have to remove this disease in this upcoming real world. So here proposed hybrid gray wolf optimization and convolution neural network. Only we have to identify what is the diabetic foot ulcers is present, what is the patient condition, and how to analyze it, and that will that will give the excite what is the patient situation is there, how they can how the disease can be affected, and what level it can be affected. So so that is our major problem. So that is solved by gray algorithm, optimization algorithm. So this is the sum of the results. So yeah, that is uh, LPP for the normal image, separating a digital image into smaller one. This is the image. Then region, how do you segment the region segmentation from this original image? So this is for clinical assessment of diabetic foot using hyperspectral imaging. So this is one results for region segmentation. So this is another image, input image for how the loss of protective sensation is there for analyzing the diabetic foot. So this is how the filter image, how do you segment it, and how what are the ways you have to excite the future, and how do you classify whether the for stage one it is a stage one stage, and stage two it's a critical stage, so you have to avoid it. So from this health factors, we have another one terminology is that is onboard processing. What are the challenges for this one? Network structures. So you have to target detection is the major one, and data compression, pre-processing, spectral resolution. So these are the challenges in onboard processing. You have to challenge, and you have to solve the problem of onboard processing using a FPGA, that is a field programmable gate array. So apart from this machine-to-machine technologies, enabling devices with same capabilities that will communicate directly over wireless or wired networks. So that will overcome by HSI and HRD technologies. So the proposed technique is only a new analytical one. So full potential of hyperspectral imaging and high resolution imaging has not yet realized. So what do? You have to the cost is also comparing this one is very high. So to overcome this hurdles, researchers what they do to find new ways to program for hyperspectral satellites. So to sort out these issues, the user wants to transmit only the most important image, less like for us both the transmission and storage of the much data could improve difficult and costly. So for this, I will give some few examples for the practical section. Hyperspectral, how do you use the hyperspectral image processing in Python, and how to display the hyperspectral image with Spy by using Python script. So I give two sample data for using this hyperspectral image processing in Python using the custom ROA selection with mouse. So you want to import all the necessary libraries, that is import IM show, get RGB data, that is the next importing some spectral libraries like so in the only you have to display the hyperspectral image, and you have to import all the numpy and MATLAB lib pyplot and MATLAB lib also you have to import it CV to import, and you have to import OS, import Pantos, so all importing files, and you have to read the hyperspectral image by based on the white reference and dark reference. So white reference is the reflectance from the white calibration surface. Dark reference is reflectance from dark only. So you have to calibrate these references and you have to normalize the data. Okay, using the equation, that is corrected image is equal to raw reflectance, that is the ratio of difference between the raw reflectance and dark reflectance to the difference between the white reflectance and dark reflectance. So finally, how to normalize corrected image based on the divide NP subtract function. So this is how do you read the hyperspectral image data using this. Next, finally, we have to view the hyperspectral image, getting the RGB data with the corrected bands and bands equal to none. So, and finally that normalize CV2, so CVT dot normalize function, you have to call it. That is, you have to define it, the alpha value, beta value, and finally, you have to rotate the function, CV2 rotate function. So this is the viewing the hyperspectral image. So any hyperspectral RGB image using this formula, you have to view it. So some of the important function for this one is, first 3 steps you have to make it. One is get right click event and extract the ROE from click point. And third one is region of interest from all the click points. So you have to first extract bounding bars, you have to take it. Second ROA, you have to take that bounding bar box with representing the coordinate values. Next, these are the 3 important functions that you know. Then you have to select the region of interest. So this is how do you get that average reflectance of all pixels in the ROA. So you have to take the integer value, and that is to be keep it as null, and get for I is range with respect to ROA. Region of interest, that is equal to ROSI. So take the intensity and you have to append the intensity with the help of mean value NP dot mean. So this is a program representation for this getting the average reflectance. Finally, show the final image with ROA using CV2 dot window normal. So main window is to be that is main image is to be displayed in this form, that is in this command. Here CV2 rotate image, you have to take image cell comma CV2 dot CV2 rotate 90 clockwise. You have to take the clockwise direction, and finally CV2 wait key until it is becomes 0. You have to final image with ROA is to be displayed. So this is the plotting. How do you plot the average? Based on this mean reflectance, that is wavelength versus reflectance curve, you can get it from this plot X label and plot Y label function. So finally show the plot based on the given RGB data. So this is for how to classify hyperspectral image with SPY by Python script. So first importing is main function. So here Landsat one image you can take it from the open image function. Finally view the IM show image with this bands, and you have defined the IM show value with this function, and importing MATLAB lib pie plot and importing all settings, and finally view the image view. So this is for Python script program. Using Python script, how do you display the hyperspectral image? Finally, Landsat open image is to be displayed in Python script. Okay, thank you. So 10 minutes is more time I discussed in this topic. So
It's okay. Thank you, ma'am. Thank you for the brief explanation regarding that hyperspectral imaginary. Saranya, ma'am.
Ma'am, I'm Saranya. My question is, how does hyperspectral imaging work?
I can't get it, ma'am. What?
Can you hear, ma'am? How does hyperspectral imaging work?
Imagery. You are asking hyperspectral imagery. So it's a continuous narrow bands. So you have to collect the bands from the electromagnetic spectrum. So normally human eye view only three spectral ranges: red intensity, green intensity, and blue intensity. So apart from that, our human visual data, so it can predict that is invisible range also. That is near infrared range or above infrared range also we can predict it from the hyperspectral data.
Thank you, ma'am. Any question from other participants? Any questions? Any questions from other participants?
Students, you have been listening long more time regarding the hyperspectral. Ma'am is an expert in this field. Can you give your clarifications from ma'am?
Any more questions? If you have, you can raise it. Okay. Thank you for giving the opportunity for delivering the lecture about perspective and challenges in onboard processing of hyperspectral imagery. I thank you, Sadish Kumar sir and his team. I thank all the organizers for make me this workshop is a grand success. I really happy about it to deliver the lecture. I thank you once again for all the participants who are all patient to listen my lecture. Thank you.
Thank you, ma'am. Thank you, Devi, ma'am. Shall we go for a vote of thanks? Saranya, ma'am, you can proceed a vote of thanks.
Good afternoon, everyone. It is my great privilege to extend a heartfelt thanks on behalf of the Leilani Publication and Trust and all the participants of the second national and workshop on a perspective and the challenges in onboard processing of hyperspectral imagery. I would like to extend our sincere gratitude to Dr. Arumugam Devi ma'am, Manonmaniam Sundaranar University, for their enlightening and insightful presentation today. Her expertise in hyperspectral imagery and onboard processing, coupled with her passion for research, has provided us with a deeper understanding of the challenges and innovation shaping this field. Your thought on data acquisition on real-time processing techniques and application have undoubtedly enriched our knowledge and will inspire future research. Your addresses has given us new perspective on the complexity and the potential onboard processing technologies. As we look forward to further engagement in hyperspectral imaging, your presentations today serve as a milestone in our academic and professional journey. Once again, we are incredibly grateful to Dr. ARUMUGA Devi ma'am and all our participants for making this workshop a great success. We hope to carry forward the momentum of today's discussion into our ongoing research and collaborative efforts. Thank you all. Thank you once again. Thank you, ma'am. Thank you, ma'am. Thank you, sir. Thank you, Mrs.T, ma'am.